Welcome to Civil Engineering Knowledge Channel. So today I had come up with one of the most required topic, that is how to calculate quantity of steel in column. So we all know that the steel, the part of steel in columns and any members of the structures is very important. So columns are crucial structure elements in building as they support weight of the structure above and transfer it to foundation. So we all know that they provide an vertical support and help distribute the loads evenly, ensuring stability and both integrity of the building as well. So there are two things that we need to focus on. One is ties, okay? The other one is longitudinal bars. So these both terminologies in column plays a very important role, okay? So if I want to explain what are these ties, so we all know that ties, so it is nothing but at the uh, surface of the column or at the center while placing the columns, and these ties are very important. Okay, so ties, it's also known as lateral ties or transfer reinforcement. So these plays a very important part in column. For what is the importance of the ties? So it resists lateral force such as wind, earthquake. Okay, so they also prevent the column from buckling or falling under these forces. So if I need to say longitudinal bars, okay, longitudinal bars are also known as main reinforcement, okay, which is essential for strengthening columns by providing tensile strength. So how do they resist tensile forces? Okay, so they resist tensile forces that occurs due to bending or lateral loads, help them to provide column from cracking or collapsing. For example, okay, if there is an what we called lateral force on the column, okay, so what would happen? This particular column may bend. Okay, so these longitudinal bars will help them to prevent the column from buckling or to prevent the column from cracking or collapsing. So these bars typically embedded with column to enhance structural integrity. Okay, so this is what the basics of ties and longitudinal bars, and also will help us understand what is the importance of these in place of column. Okay, so when we plan any structure, okay, so it's very much required that we need to plan what is the quantity of the steel that is required while calculating the column. So what I'll do is, I had taken one as an example. Okay, so that is one single column. Depends upon that, you can calculate weight of steel for all the columns. So for example, if the building has 100 number of columns, so whatever the weight of steel that you get from this calculation, you can multiply that particular steel by 100. So you will have an understanding for construction of the column what is the weight of steel that is required. Okay, so we'll start. The first one, that is how to calculate quantity of steel in column. So I had taken this column as an example, okay, where size of the column is 9 inch by 9 inch. So you can see this is the size of column from the top view. This is a top view and this is a side view. Okay, so from the top view, the length, that is size of the column is 9 inch by 9 inch. So what is 9 inch when we convert it to mm? That is 225 mm into 225 mm. So what is the leg length? Leg length is nothing but the extended portion that is provided at the end of the column to support. Okay, so the leg length, it is nothing but It's a 300 mm. So when we convert it into meter, that is 0.3 meter. So what is the height of column in this case? Height of the column we had considered as 3.6 meter. Okay. So and these are the reinforcement. Also this particular what you see right inside bars. So this is nothing but this extension what I had drawn from one of the side view. Okay. So these are the bars, and these are the hooks. And here the cross section part what you see right, this is nothing but the concrete cover. For example, when you build any structure, you will place a steel, but you will provide an wooden cover, right? Wooden cover, whatever the gap is there, no, that is nothing but the concrete cover. When you pour concrete inside these, and once it is removed, you can find the concrete structure. That is nothing but the concrete cover here. So that concrete cover, it's been taken as 25 meter. That is, if we consider 25 meter, that is 0.025. Okay. So let us start calculation of the steel. Okay. First, to calculate steel, first we should calculate length of one bar. Okay. So what is the length of one bar? That is height of column plus leg length. What is the height of the column given here? That is 3.6 meter. And what is the leg length given? Leg length is nothing but the extended portion which I had explained you. That is 0.3 meter. So 3.6 meter plus 0.3 meter, that is, when you calculate, that is 3.9 meter. Okay, this is the length of one single bar. This one single bar, it's a length. Okay, then so what is the total length of the longitudinal bar? We have how many bars? 4 bars. So here you can see how many bars we have, that is 4 bars. So what should be the length of entire longitudinal bar? I mean, that means the total. So we have 4 bars, 4 into length of one bar, that is length of one bar is 3.9 meter, and number of reinforcement, I mean that particular bar what we have is 4. So 3.9 into 4, that is 15.6 meter. Okay. Next, length of one tie. So how do you calculate what is the length of one single tie? So that is nothing but size of the column minus, so here size of the column minus, this is 1 and this is 2. So 2 into 2 sides of the concrete cover. How many sides we have? That is 4. Multiply by 4 plus 2 hook length. So 2 into hook length. What is the hook length provided here? That is, hook length is nothing but this particular portion. So in separate if we take, that is 0.075 meter, that is 75 mm. Okay. So here length of one tie is nothing but size of the column is 0.225. Here you can write, understand, right? This size of the column, that is 225 mm. That is in meter we are writing 0.225 minus 2 sides of the concrete cover, that is 2 into 25 meter into, we have 4 sides into 4 plus 2 into hook length. 2 into, what is hook length? That is 75 millimeter. When you write it in meter, that is 0.75 meter. So when you add all this value, that you will be getting 0.726 meter. So then we should calculate total number of ties. How do you calculate total number of ties? Total number of ties is nothing but these. Okay. How do you calculate that? How many number of ties are required? That is nothing but height of the column. Then what is the difference between each these particular steel? Okay. That they had given 8 millimeter dia with 150 mm spacing. So this spacing that we are calculating here, total height of the longitudinal bar, that is from here to here, I mean this is 3.6 meter, that is 3.6 divided by spacing. Spacing is nothing but 0.15 in meters. Okay, so 24 numbers of the bars are required for this entire length. Okay, then so what is the weight of longitudinal bar? So when we know that total length of this entire longitudinal bar is 3.9 meter, and we also know that that is 4 numbers are there, then how do you calculate weight of longitudinal bar of that particular 4 numbers? 4 into weight of length of one bar, that is 3.9. Total weight is, total length is 15 total numbers, that is when you calculate 4 into 3.9, 3.4 is nothing but bars and 3.9 is length. So length of 4 bars we will calculate here total together. Sorry, I told it wrong. That is length of total 4 number of bars is 15.6 meter. How do you calculate then weight of total longitudinal steel required in the entire column? That is weight of 4 bars, that is 15.6 meter into, length, total length of the 4 bars, that is 15.6 meter into 0.88. How do you calculate this 0.88? We know weight of the steel formula is, that is D square divided by 162. So what is the D for longitudinal bar that we had considered? That is 4. Dia. D is dia, that is 12 mm. So what is D here? You need to consider 12, that is square, that is D square divided by 162. So when you do that, you will get 0.88 kg per meter. Okay, so that is what we had considered this particular number. So we will understand how much kgs of longitudinal bar that is required for one single column, that is around 13.72. Approximately we will be taking it as 14 kgs. Okay, so then weight of ties. So weight of ties is nothing but, we know that there are 24 number of ties that we had taken. Okay, so how do you calculate 24 number of ties weight? So it is nothing but 24 into length of one tie. So what is the length of one single tie? That is 0.726 meter. So if one is 0.726 meter, then for into total 24 when we consider, what is the total length of the ties? That is 17.42 meter. Okay, so this is the total length of the ties for 24. So earlier we had calculate, if you just now I had said, when you calculate longitudinal bars, we know that one is 3.6 meter. We have 4 number of the longitudinal bars. So 4 into when you calculate 4 into total length of one bar, that is 3.9, we got 15.6 meter. That is for longitudinal bars. Similarly, since we know that there are 24 number of ties, and length of each tie is 0.726 meter. So 0.726 meter into number, that is 24, when we do, we will get 17.42 meter. So how do you calculate total weight of ties that is required for one column? It is similar, that is total length of ties in entire column multiply by weight of the steel formula. Weight of steel is nothing but D square by 162. What is D square here? That is, we had taken, if you remember, diameter of this particular tie is 8 millimeter dia. So it is, D should be 8. Okay, that is D square is 8 square by 162. So when you calculate all this, you will get approximately 6.88 kgs. Approximately we will be taking it as 7 kg. So to calculate, as I said you earlier, so to calculate what is the total quantity of the steel required for entire column, it's very important to consider longitudinal and ties weight. So this particular weight will help us understand total number of steel that is required for entire single column. Okay, so what is the length of total weight of the longitudinal steel? We know that that is 14 kg, and total length of the ties weight, that is 7 kg. So 21 kg is total number of steel that is required for entire column, that is one single column. For one single column 21 kgs is required. So as I said you, if there are 100 or if there are 12, if there are 8, depending upon type of the building, whether it is commercial building, whether it is school building, whether it is house, whether it is small shop, so depending upon the plans, you will know how much number of the columns are required to construct in that particular plan. Accordingly, for example, if we have 12 number of columns, then how do you calculate 12? What is the quantity of the steel required for 12 number of the columns? That is simple, 12 into 21 kg, that is weight of steel for one single column. So it is approximately 252 kgs for one single floor plan. If there are 12 number of columns, then we will calculate total weight of the steel with the help of multiplying one single column weight multiplied by 12 numbers. So I hope this is useful video when you calculate for number of steel. So also you should have an understanding where how column placing is important. So in an environmental context, okay, if I need to explain what is the use of ties and longitudinal bars in column, so it helps to improve sustainability of the structure by enhancing their durability and longevity. What do you mean by durability? Durability is nothing but the lifespan, and longevity, that is how strengthful that you are trying to build a column that will be staying for a number of years together. For example, if there is an earthquake or any environmental hazard, okay, so the design of these columns and the reinforcement that you use for these columns will prevent from all these hazards. And reinforced column that helpful for the energy could be required for reconstruction, okay, and also this aspects align with principle of sustainability construction practices, so which aims to minimize environmental impact through structural life cycle. So in general, if I need to say, this particular ties in general we will have an understanding where what is the importance of this ties and longitudinal bars in case of the columns. I hope this video is useful. Also the whatever the theory that I had explained in this video, so I will include all these things in video descriptions, so you can just go through the video first, try to understand how to calculate the steel of the column. Also, to explain what is the importance of these in case of column, so I will give those descriptions in the description tab of the video, so you can just try to save that video and try to share this with your friends as much as possible. So since it is very useful in case of examinations, where if you are preparing for your annual exams, also if you are doing if you are a fresher and joined any company where you wanted to know what is the basics of that, you'll have an understanding as well. So let me include all those things, and if you require any future video or on any one of the specific topic where you want me to explain the theories, I'm happy to explain. Please mention in the comments, so I'll take this in future. So as much as you people share the videos, it's helpful for me to get uh, on what topics that you wanted to have an understanding. So I'll make sure to project those topics. So yeah, thank you. Thanks for watching the video. Kindly share, kindly subscribe.